radiation, when they come back to their original states, this phenomenon accounts for the emission spectrum through hydrogen too, better known as the hydrogen emission spectrum. This is the hydrogen emission spectrum starting from the gas discharge tube containing hydrogen. This hydrogen is passed through the slits, the light, and the slits which filters off, which is passing through the prism, and you will get the spectrum on the plate, photographic plate you can say. In the late 1800s, in the 18th century, it was known that when a gas is excited using an electric discharge and the light emitted is viewed through a diffraction grating, the spectrum observed consists not of a continuous band of light, but of individual lines with well-defined wavelengths. The experiments have shown that wavelengths of the lines were the characteristics of the chemical element emitting the light. They were an atomic fingerprint which resulted from the internal structure of the atom. What is hydrogen spectrum? First of all, before knowing to this hydrogen spectrum, you should know what is meant by a spectrum. Spectrum is a phenomena occurs when the light ray passes through the prism. You will get the spectrum of light with Gaillard, that is violet, indigo, blue, green, orange, red colors have been formed on the photographic plate. So the hydrogen spectrum is an important piece of evidence to show the quantized electronic structure of an atom. The hydrogen atoms of the molecule dissociate as soon as an electric discharge is passed through a gaseous hydrogen molecule. It results in the emission of electromagnetic radiation initiated by the energetically excited hydrogen atoms. In the excited state of atom, the photons emitted, and hence the spectrum will form on the photographic plate. My dear friends, the hydrogen emission spectrum comprises radiation of discrete frequencies. These series of radiations are named after the scientists who discovered them. That is Lyman series, Balmer series, Paschen series, Pfund series, etc. When n is equal to 1, you will get Lyman series. When n is equal to 2, you will get Balmer series. When n is equal to 3, you will get Paschen series. When n is equal to 4, you will get Pfund series. These are the way of getting the spectrum of hydrogen. Lyman series V is equal to RC 1 by 1 square minus 1 by n square, where n is equal to 2, 3, 4, and Balmer series is similarly it follows the equation. Hydrogen spectrum wavelength. When hydrogen atom absorbs a photon, it causes the electron to experience the transition of higher energy level to lower energy level. For example, n is equal to 1 and n is equal to 2 when photon is emitted to the hydrogen atom. The electron undergoes a transition from higher energy to lower energy level. So V is equal to 109677 multiplied by 1 by 2 square minus 1 by n square, which is the important thing developed during the spectrum formation of the Balmer series. The transition from first shell to any other shell, Lyman series, transition from second shell to any other shell, Balmer series, and transition from third shell to any other shell, Paschen series, etc. It continues. Johannes Rydberg, a Swedish spectroscopist, derived a general formula for the calculation of wave number of hydrogen spectral line emission due to the transition of electron from one orbit to another. The general formula for the hydrogen emission spectrum is given by hydrogen emission spectrum equation, where n is equal to 1, nu is equal to 109677 multiplied by 1 by 2 square minus 1 by n square. This is the equation where R is the Rydberg constant. This is the spectrum of Lyman, Balmer, Paschen and Pfund series respectively, my dear friends.